In question 1, we're going to use the graph of y equals f of x to answer a through d. To start with, what's the domain of the function? That's all the x values that correspond to the points on this graph. So starting with this point here, this is the corresponding x value. So I'm going to mark that at it's -3. And as you travel along the graph going in this direction, you get all of these corresponding x values. And that doesn't stop until you get to here. And the corresponding x value for that point is, it's not negative, it's +4. So that means the domain of this function, which I'll call d, is equal to the interval from -3 to +4, and I'm using brackets to indicate that I'm actually including both -3 and +4. So we get everything in between those two x values. And we have nothing outside. Like, I wouldn't include any of the x values here because, well, if you look up or down, the graph doesn't exist, and that's true for every point over here, as well as every point over here. Okay, well, what about the range of the function? Now, this is the set of y values. Again, if you look at the points on this function, the y values, if we start with this point here, looks like that is +2. And as you travel along the graph and head in this direction, you get all of these corresponding y values until you get to, well, right about here, and then I have this y value, which looks like it's -3. So for this graph, all of the y values are between -3 and +2. Like if you look up here and you look to the left and the right, the graph doesn't exist. If you're down here and look to the left and the right, the graph doesn't exist. So therefore, the range, which I'll call r, is equal to the interval from -3 to +2. Again, we are including those two endpoints, so I use the closed brackets. And we always list the values from smallest to largest in interval notation. Okay, find the coordinates of the x-intercept. So this is where the graph is crossing the, or is equal to the x-axis. So that appears to be here. Okay, so the coordinates for the x-intercept, well, the x value is -1 and the y value is 0. So -1, 0. There are no other x-intercepts, so that's it for this problem. And the last thing here is, well, what's f of 2? So what f of 2 means is, what is the y value when you put 2 in place of x? So if you look at the graph, here is x is equal to 2, and the corresponding y value is -3. What all of this means is that f of 2 is equal to -3, and that is the answer for part D. For question 2, we want to match the correct function to the correct graph using our knowledge of transformations. And it might be worth starting by looking at the original function x squared. So if you were to graph g of x is equal to x squared, the original function, it has this shape to it. And maybe just to label a couple of points, like I know it has the point 1, 1, and -1, 1. But anyways, that being said, how are these functions different than this one? I'm going to make a few notes next to each equation just as a guide. Like starting with a, I see this x plus 2 squared. I know this plus 2, since it's right next to the x, it's inside the function. I know it's changing the x value, and it will have the opposite effect that you would expect. I'm thinking this graph is going to go left 2. You might think it goes right 2 places, but it should actually go left 2. Compare that to b. This -3 is outside of the function, so it's changing the y value, and it will have the effect that you expect. In fact, this is going to go down 3 places. Okay, here we're multiplying the y value by 0.5. So again, we're changing the y values. And multiplying by 0.5 is the same thing as dividing by 2. So we're going to take half the y's, or the y values. In part D, there are 2 changes. I see there's this negative and there's this +1. So the +1, it's changing the y value, so that's going to be up 1. And multiplying by a negative, and here we're changing, again, the y value, it's going to reflect over the x-axis. And the order in which it will happen is, well, first we would multiply and then we add. So there are actually two steps in this one. Step one is going to be, well, we'll reflect, and this will be over the x-axis because we're changing the y values. And then it's going to go up 1. So both of those things. All right, I think we're ready. Okay, I'm looking for a graph that is left 2 from this one. That's this here. The graph certainly moved 2 places to the left. So for 4, I'm going to put in A. All right, done with this one. Okay, this one is down 3 from this original graph. That's clearly this one. Here, this point starts at 0. Here, it's down 3. So therefore, B goes for 3. Let's see. For this one, if we take half of the y's, okay, that appears to be this graph. Like if this is the point 1, 1, here 1 is at a half, negative 1 is at a half. It's got to be that C is for 2. I mean, by process of elimination, I know this one is going to be graph 1, but this thing is definitely reflected, right? It's upside down, and then it moved up 1 place, moved up 1, so it's got to be that 1 and D match. And that is it for this problem. And for question 3, here we want to find a composition of the functions with f and g, and then determine what the domain of this function is. Okay, so for starters, what is this? What is the definition of f composed with g of x? So the definition says you take the function f, so that is this thing here, but wherever you see an x, you're going to replace it with the function g of x. That's this. So I view it as follows. I look at the function f, it's 2 divided by x, but any place I see an x, I make a substitution. I don't multiply, I don't do like x times x plus 5. This thing actually gets substituted in place of this x. So for emphasis, I'll put some parentheses to represent where this x is located, and I'm going to plug this function in. So I'll put x plus 5. And of course, you don't really need to write it with the parentheses, so you could just put 2 over x plus 5. And that's it. So the composition of f composed with g is this equation here. Now, the second question is, well, what's the domain of this function? What x values are you allowed to put in place of x? So I like to think about what goes wrong, like what could go wrong if you have, in this case, a fraction. And the thing that can go wrong is division by 0. Division by 0 is not allowed. So if I see a fraction, I immediately think this, and I ask myself, what number, when you put it in place of x, would put a 0 into the denominator? I can see that the number is -5. You don't have to show this work, but if you'd like to, you could say, well, I'm looking to see where the denominator is 0. And I know to solve for x, I would subtract 5 from both sides. And that would give me x is equal to -5. So I'll make a note that this makes the denominator 0. And that's a problem. We don't want to divide by 0. Every other number works. There is no other number that when you put it in place of x, it'll put a 0 into the denominator. So this is the only thing that we want to exclude. This means the domain, there's a couple of ways you could write it. You could say, well, the domain is every single x value except for -5. That one's no good. If you want to use an interval notation, you'd express it as follows. That's everything from -infinity to -5. I'm using parentheses to indicate that we're not including either of these values. Then you want to include everything from -5 to +infinity. You put this union symbol between them to say, I want to include both of these intervals in my answer. So expressing your answer like this is fine. As an interval, this is acceptable too. And that's it for this problem.